The Adelaide Desalination plant provides a source of drinking water for South Australians that is climate independent. The plant removes impurities and salt from seawater, turning it into clean drinking water. So even in times of drought, South Australians will always have a reliable supply of drinking water available. It provides South Australians with confidence, like an insurance policy, providing security to all SA Water customers, businesses and industry. But how does it work? How does the desalination plant turn seawater from the Gulf of St Vincent into water that's safe to drink? The core technology used is called reverse osmosis. First, let's explain what osmosis is. Osmosis is a naturally occurring process in which a liquid, such as water, spontaneously passes through a membrane. The membrane or semi-permeable barrier allows some molecules, like water, through, but other molecules, like the majority of salts, are unable to easily pass through the membrane structure. The flow of liquid through such a membrane occurs naturally to try and even out the salt concentrations between the two solutions. That is, the liquid flows from the less concentrated solution, such as fresh water, to a more concentrated solution, such as seawater. When the direction of liquid flow is reversed, it's called reverse osmosis. By pressurising the concentrated solution, in this case seawater, we are able to force water molecules in the reverse direction, from the salty seawater side through the membrane to the freshwater side. At the Adelaide Desalination plant, there are several stages that the seawater goes through on its way to becoming clean drinking water. Seawater flows by gravity through a tunnel to the plant. Band screens remove coarse solids from the seawater before it is pumped into the plant. Disc filters clean the seawater further, before ultrafiltration membranes remove very tiny particles, including bacteria and viruses. Now it's time to remove the salt from the filtered seawater by reverse osmosis. At the heart of the reverse osmosis process are the membranes. Each membrane has 3 layers: the support backing, the porous support, and the thin barrier layer through which water can pass easily while the majority of dissolved salt molecules and any remaining impurities cannot pass. When a reverse osmosis unit is made, these membrane sheets are folded, stacked, and glued in such a way that when pressure is applied to the incoming seawater, the freshwater molecules can move through the membrane's barrier layer, leaving the salt molecules behind. Spaces between the membranes allow room for the incoming seawater and outgoing desalinated water to flow easily. A tube on the end of the membrane sheets collects the desalinated water that is produced. However, the final reverse osmosis unit is not flat. The many layers of membrane and spaces are rolled around the central tube, creating a cylinder shape, which is called a spiral wound unit. In this form, a very large membrane area can be packaged into a small-sized unit. At the Adelaide Desalination plant, 8 of these spiral wound units are loaded into a white fiberglass tube called a pressure vessel. For reverse osmosis to work, the filtered seawater is brought up to a very high pressure using high-pressure pumps. The pressurised seawater is then fed through a bank of pressure vessels. The majority of the dissolved salt molecules cannot pass through the membranes and are rejected. As a result, the feed water becomes enriched in salts as pure water is removed progressively by each of the 8 spiral wound units in the pressure vessel. The rejected seawater is now called saline concentrate liquid and is largely indistinguishable from seawater, aside from its higher salt content. The saline concentrate liquid, which still contains most of the pressure supplied by the high-pressure pumps, leaves the rear of the pressure vessels and is directed to an energy recovery device. Here, about half of the new incoming filtered seawater is pressurised by transfer of energy from the outgoing saline concentrate liquid. This transfer of energy recovers nearly all of the energy originally put in by the high-pressure pumps, decreasing the plant's overall energy requirements by approximately 40% and further reducing its environmental footprint. The energy recovery devices significantly reduce the plant's operating costs. Meanwhile, the desalinated water, which is passed through the membrane surface, flows along the pure water channel and into the central tube for collection. This water then passes through a second set of pressure vessels containing more spiral wound units to remove more salts. This desalinated water is then piped to the post-treatment area and is treated with lime, chlorine and fluoride, which improves the taste and makes the water safe for distribution and drinking. Through the reverse osmosis process at the Adelaide Desalination plant, for every litre of seawater that enters the plant, about half a litre of clean drinking water is produced. The plant is capable of delivering 100 gigalitres of clean drinking water per year. The Adelaide Desalination plant has an innovative and sustainable design, reducing its carbon footprint and ensuring it will remain operational throughout its projected 100-year lifespan.